So let's continue so then we can finish it quicker. So in the previous lecture, part of the lecture, we talked about overloading, right? So we define our own versions of the operators, of the ones used in C++. Also, we explored the concept of a friend, meaning it's a special function, in this case right here, which, well, it has to use a stream, that's why you have to use a friend. So the point is it cannot be a member function in this case. Here, well, I think you could get by without using a member function. These are member functions, right? But here you have a friend. Of course, we could define also some other generic friend function which is not related to overloading. For example, well, again, comparison. Of course, we could compare, right? Whether which time is quicker, right? Keep adding these functions. For example, comparison would be also a possibility. But okay, let me finish this. Welcome back, everyone. All right, so I will just couple syntax errors fix, syntax grammar fix, syntax fix, and of course. Now we can go to the second part of the lecture, which deals with stream. We talked about this stream, right? We need a friend then, right? Prototype, which we just explored, right? Right. So plus, right? We did this here already, right? Right. So as non-members, we have to return, you see, as a non-member function, right, we have to return the actual object, right, of course, but again, so that would be the syntax if we have to do it with a friend, right, so again, binary operators like plus, right, can be done either way, right, so as a member function, you have direct access, right, so it's much easier, that's what we did here, right, with both, you have to pass both parameters, right, and, well, sometimes it can be clearer, right, so also can be tricky with pointers, right? Of course, right? Because assignment, of course, copies member variables from one object to another. Does not work well with pointer variables. So class with pointer variables, right? You must explicitly overload the assignment operator, and then you have to make a copy constructor, destructor. It gets pretty messy, right? So you can even overload the array operator index and things like that. Okay, so. Function, right? We can overload function, of course, right? So now let's talk about the templates, or second topic today. I'll make a new file. Templates is the one big idea again. In a C++, we have very strict, static types, dead types for many, functions. Also for classes, we define strict types. With templates, we can avoid writing the same function over and over and make a generic function, like a generic swap function, generic minimum function, generic max function, for example, right? So let's call them the templates and generics. Templates, generics, right? C++, right? Let's explore templates and generics in C++, right? Idea. Yeah, and these templates lets us, generic function and classes. Okay, so I including a stream. Come on, I don't want to write IO stream, right? I'm using namespace. And of course hash. That's why it complained, of course, right? And using namespace, right? Using namespace std, right? And so. Let's see what the book shows. What kind of idea, right? So basically, we avoid specifying a specific data type, right? That basically it's possible to have multiple types also, right? So define a generic function, for example, finding a minimum, right, of two values, right? Let's write the template function for max. Yeah. Template, right? Yeah. All right. So that's the syntax, right? So this means that, of course, we are saying it's a template function, right? So it returns, what does it return? So same type, so T, 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 in this particular case, right, I'll call it my max, right, not to not have any problems, right, my max, right, returns the same type. So in above function takes 2 of type T, return the max of 2 arguments which is the same type T. Okay, so what can be type T? Well, yeah, exactly. So if you want to have a maximum of our our previous example, so if we had our own class, yeah, and use it, we can overload it, and then we can use it, right? So it goes together with what we just learned, right, in previous part, if you wanted to. Okay, but let's explore it. So let's see my max. Let's work. Of course, we use ternary operator. We use ternary. Yeah. Okay. So whichever, if A is bigger than B, you return A. Otherwise, you return B. Right? Simple. So let's do this. Int main, right? Yeah. So it will work with what? 3.7. Hello world. AZ. Right? Anything. Right? That can be compared. Right? So I will do this, of course. Yeah, like this. Right? Hopefully, since I'm lazy, let's see. Let me make. All right. So to show you that. To show you what I'm doing, basically, right? Since I'm lazy. So is everyone back? 1, 2, 3. Yeah, 9. So Elsa is sick, right?
Yep.
Okay. So she didn't have to come. She could have done this, makeup test, I guess. But maybe. All right. So. All right. So okay. All right. Let's see. Look. Let's see if this compiles. It should. All right. Well, of course, here we have a problem, right? How would the fact that I had probably escape, right? Probably this should work. Oh, well, it's not Latvian. Oh, so I don't know Latvian language. Sorry. We'll change it. Shift out and Windows. Right. English. Right. English. All right. Escaping should work. Yeah, that works. Right. Yeah, that should work. Now, are we good? We are good. Right. Okay. Let's compile this. So. Templates, right? Sorry, output, right? Yeah, output. It worked. Yeah, it compiles. That's good to know. Yeah, so maximum. Let's look at our. So maximum of 3 and 7 is 7. My max of 3 and 7 is of course 7. A and Z. Z again ASCII, right? And same thing. Hello and world, of course. H. Right, and W, right? Well, hello is more than W. Why is that? Let's see. That's a good question. Okay, let's see. I forget now how the actual comparison on we don't have string. These are C-type strings. How the heck does it work actually now? That's a good question now, right? Because we're comparing these two strings. These types have a comparison, right? Good question. Why is it world? I'm getting hello here, right? Maybe no, but I'm giving here H. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good question. Why is A more than B, right? That's more. What's more of a string question, right? So let's do C string question, right? So let's do a regular string, right? Let's do the string you should be using in your midterm, right? Let's use include string, yeah, of course, and we'll make it also, right? That makes string. Yes, one is hello, right? String is 2 is world, and let's compare cout. Yeah. Let's see. It should be world now, right? Because W is after H, right? right? That's I think. So I'm trying to see if this is what's the issue here. Why is hello being returned? It should be world. It's getting hello. Kind of weird, right? Right. The hello world. Yeah, that of course is just a syntax sugar. Let's take a look. Compiles. Yeah, we get world, which is as expected. So this is interesting. This is something to explore. Again, you don't. Again, I'm trying to remember why C string comparison. How the heck do you compare C strings actually in general? Right, the same length in this particular hello world. Why is it? It's not adding. Surely it's not adding all the ASCII codes together. That would be kind of silly, right? HELLO. Right. You need to see how our C++ strings are compared, right? C plus reference C string comparison. How was it actually done? Yeah, you can. That's in C, right? C++ actually. C++. How actually it does something, right? Yeah. So string comparison. So this is it's doing something. Maybe it's comparing the last one. Maybe it's returning the pointer. Surely not, right? So this might not be what you want, right? Okay. But this is proper as expected. Okay, so that's good. Okay, so all we did is, right, we avoided doing all the work for each different type. So anything that is legal here, right, for these types, this is defined for this type, right, then we can compare it, right? And that's the basic idea behind generic functions, right? So what do we have here, right? Same goes for the class, right? We can also similarly do a class, a generic class. Meaning, so this leads to we can make a generic data container, basically generic data structure, which can hold anything, right? Any data types, right? That's how it's actually done. How vectors, how sets, which I saw. I was really happy to see you using sets and vectors, right? They are generic, right? Because you can take pretty much any data type, right? Which included, right? And you can store them, right? So let's make a generic data class, right? Now, so let's make a generic class. Let's make a generic class of stack, right? So what's a stack? We'll talk about this more in body structures, right? Stack. Excuse me? Yeah, first out. Yeah. Last in, first out, right?
Yeah.
Last in, you get out like stack of plates, right? Stack of plates, last plate, you get the last plate. You know, maybe not fair, right? If you're going, it would not be fair if you were waiting in line for something. That first last guy comes and he gets to be served first, right? That would be, but we use the queue structure then, right? Yeah. But so we will define a class template for stack with basic push, pop, and top operations. So template, right? T, and it's going to be of course class. Of course right? So class stack private. We have pointed to data, right? And we allocate size, right? New size stack, right? Size. We pass the size, how much stuff we store. Top, right? Initialize top to -1. Question is, this means there's nothing, meaning there's no index, basically, right? So we push, right? Stack is full. So the reason this works is, of course, that this new operator, right, is dynamic, right? Doesn't matter what data type you have. This is something integer, float, right? It will allocate exactly how much you need, right? So we also, of course, need to store the size, otherwise things will break. And of course, -1, this is, just convention, of course, because we don't have any element at the moment. We have an empty stack, right? And push, right? If top, okay, so in this particular case, basically we check, we have a sanity check, safety check, right? Stack is full, right? We have a message, okay? And otherwise, right? This is early or sanity check. Otherwise, what we do is it's a void function, right? So, right, we saw early return, right? Right? And data plus top element, right? Again, it's usually people, it leaves less bugs if you prefix, right? Prefix plus, right? You add this something top and then, so why? So basically, it's actually two operations, right? This is what C++ and C does a lot, right? So actually it's two things. We increase the top, right? So this is crucial, right? If you did top plus, probably not what you want, right? You override the last plate, and you put a new element. So this would not be a good idea. So that's why you need pre-increment. Note the use of pre-increment operator. It is crucial here, right? We could have written was as two lines, right? Right, and this is again, if you're worried, right, you do this would be completely fine, right? There's a little bit more work. Again, if you work too much with C++, you will tend to write code like this, right?
Because what's the reason why can't you insert top plus instead of plus?
Because you will dismiss top, you have the old version of top, right? Meaning you're overwriting the old version. Like here, right? If it was here, this would be happening. Remember, this line is two operations basically, right? So what happens is, if you do top, right, the precedence, right? If this was here, you would be taking, okay, you have like plate number 5, you have the new version, right? And you overwrite it, and there's new top, right? So this would be, well, it could work, but then you sort of like lagging one behind, right? So basically, you sort of like you have the first one. Let's see how it works. If what top is -1, right? So that would be a problem, right? Because -1 is not good, right? You have a -1 index, you would be overwriting something which you have no control, right? You have outside your memory, right? You somewhere, not a good thing, right? Pretty bad bug actually, right? Such a simple thing, right? And pretty dangerous bug, right? So of course, one way to avoid all these problems is use this type of slow one operation at a time, right? Yeah. Then you don't care, right? Here, it does not matter. Yeah, right. Safe, either way, right? And first, on push top will be -1, and exactly. Okay, so pop, if top is -1, we do nothing, right? We don't pop anything. Well, here pop. Right. So I remember this is again classical. Unlike Python, list type pop. Here just decrements pop, meaning it destroys basically, right? Technically, right? So you need to use this, right? Pop. It does not even care about what you're storing, right? Note here this stop. Note here this pop. It does not really remove the stack, right? But doesn't matter, right? But we, which is fine, yeah, right? In our abstract way. So top element, of course, right? Text empty, return empty, right? Default value of t, right? I don't know what actually it is, right? If it's empty top element, I wonder what heck is that like for integer. We'll see if this works, right? Otherwise, of course, very simple. Return the top. Okay, we have our stack. Let's make a stack, right? So let's make a stack of integers. Stack of int. Right? Stack integers. And we declare size. And push 1, of course, push 2. And well, hopefully it stops. I don't know. Top element, right? Pop, right? This moves the index. Right. Okay. Let's do more popping, right? Pop move 1. I want to see what happens here. Right? On top element. empty. I wonder what's going to happen here. Okay, what's the value of integer? 0? 0. Let's see. I'm curious about this. This is a good question. What do you return if a stack is empty, right? Because sometimes you are storing actual 0 on your stack, right? And so two different types of zeros, even though they are same, right? So good question. Let's see about this. Let's compile on templates. Yeah, stack is empty. All right, stack is empty. In stack top element, stack is empty. It prints here, right? It prints here, yeah, and then returns, right? So this is not technically needed, right? Well, yeah. So then you return 0. Oh no, that's not that. So technically it is 0. Okay, that works. So now, of course, the beauty of this is if I need a stack or something else, let's do stack. Let's do stack of strings, right? Sure, why not? It should work. So stack, string, string, stack, right? String of the good ones, the good C++. Yeah. Note: we do not have to rewrite. Yeah. So just need to type it. So this is a T, right? T here, right? On. Let's put some stuff in here. Hello, no, I'm hungry. Let's go, you get some lunch. Go. To grab. On, what else? One more. No, one more. Grab lunch. Shows my stomach talking here, right? Alright. No. Top element, lunch. Alright, pop. Grab. Now, I'm also curious what's going to be pop. Let's. Now let's pop one more. Let's see what happens now. Move top minus 1, and stack is empty. What's the default value of string is empty string? Yeah, that makes more sense, right? So it should work, right? And of course, I can push stuff back again, right? Compile, and it works. Yeah, let's go. Lunch, grab, go, let's, yeah, right? So stack, right? So stack, of course, is often used. So now you have a generic data structure, stack. And you go, well, here it doesn't really matter, So and this is really completely generic. There are no real limitations here, right? Because why? Because in this particular operation, it's defined for pretty much any data type, right? So we allocate the memory, right? So do we have the destructor here? Yeah, I would like to see a destructor for this as well. Let's add a destructor too, right? Let's add a destructor. Let's add a destructor. Yeah. Stack delete data, right? That's good. You should do that, right? Otherwise, it's possible you have your stacks maybe laying around somewhere, right? So, of course, I can allocate a lot of memory, right? And you end up with maybe a memory leak, right? So it's destructor delete data, free the memory. All right. Let's see what do the slides say about this, right? So template we just made it, all right? So passing a parameter to a function, of course, happens at runtime, right? But when we make a class template parameter like this T here, right? This part here, right? This actually happens at the compilation step. So in effect, it's basically we save our time of making these multiple boring functions. You do it only once. So that's how, of course, you try to do it as much as possible. Again, right? So we can make we made our own, could we compare two stacks, right? Well, so we want to use my max on a stack types, right? And that's a good question. Can we do it actually, right? How could we actually compare stacks, right? Okay, let's go with this side. Let's compare, let's think, okay. So now, let's wonder if we can do this. We're going to try to push things a little bit. Let's define a friend function that compares stacks by their sizes, right? Yeah. Yeah. Let's do this. Right. I want to. Which one is bigger, right? So. Okay, so let's do this. Friend, how was it? So T. Let me see. We got compare stacks. Let's see this if size, right? But we don't. Okay, do we have size? It's not public, right? It's public. I forget now. It's private, right? So this won't work, right? We need friend, I believe. I'm just. Right? I hope it's correct, right? So friend, compare stacks, and we need to pass 2, right? Friend T, and of course now, of course, it's not. We need another stack. One is 1, 2, right? Friend function. Let's make a. So let's make a friend function that is passed 2 stacks into the bigger stack, right? Yeah. Yeah, okay, come on, let's see. It can't, the AI is messed up, so I have to do it myself. So friend stack, okay, I think now, yeah. So we can compare the size, so we have access, and we get one of them, we get once, by size. All right. So now, of course, I'll make maybe a string stack will have like 15, right? More space, right? And now we can compare it. Now let's compare the 2 stacks. But the question is, can we do stack integers? So that's a good question, right? If you have 2 integer stacks, right? Let's compare. Or maybe, do we have a top? Well, we could have also a counter. Do we have top here, right? Right. Or maybe we should compare top actually, right? I think it makes more sense, right? We have a few more minutes, right? They are return stacks with the bigger top index. Okay, so let's get rid of this. This is good for size. Return S1 top, right? So this would compare by size. Right. Okay. Yeah, AI is getting. You see, this novel AI is losing its usefulness. This GPT, I believe, it's 4 model, right? It's losing rapidly using this context, right? It's possible also because I'm trying to do things which are not normally done. All right. So now we should be able to compare stacks, right? Let's add something. Let's add one more element. Push let's. Okay. Now string stack has 1 element. Int stack has no elements, right? Stop is -1. Stop is 0. Okay. So now we should be able to compare it. I don't know. I hope so. String, yeah, but the problem is, now stack string. So that's the issue, right? Yeah, we have a bigger stack, right? And well, it can't really, unfortunately, can't really compare. I wonder that's why I'm trying to do too much. So I probably need to compare. Let's make a blank stack, right? So we need to compare. We can't, alas, it's not done. Alas, it is not done easily, right? Fix me, that's something to do. Fix me to do. Let's instead, let's create a new string stack and compare the 2. So that could be fine, right? So string text 2, right? It should be work. A stack. string due to the generics, right? 10, right? Now we should be able to compare it, right? All right, so now it should work. What's the issue here? What did I do wrong here? String stack, because I don't need, of course, stack, string. Okay, what's up is the title here? So I should be able to see the biggest one. The bigger one. Top element, right? Bigger. Okay, so let's. Right, so it all looks good, but this part here, why doesn't it like? Stack. Oh, sorry, yes, I can't type. You see, stack. Okay. Now everything looks okay. Let's compare it. And we're almost done. We're almost done, guys. I know you want to get some food just like me. All right, so it works. So we can compare. Since the signatures. All right. So that works. So this does not affect because it has the top is -1 by default, right? All right. Now, so you see how it works, but now, of course, final thing, the sort of like the topping is now let's overload the not print the comparison, right? Bigger stack, bigger one, right? It can be bigger. We compare it. Yeah. Yeah, so that's it, right? So that theoretically should be fine. Bool operator, stack, the turn top on S top, right? So which one is bigger, right? So we can compare it directly, right? Whichever stack is bigger, right? Using this, we don't need a bigger stack, is bigger, right? So it's not quite the same, right? We can pass it, right? So now we can compare which one is bigger, right? So now that we have overloaded, we can compare two stacks. Right? Again, note again true. Note the use of parentheses. Yeah, because see the previous CLC overloading C2P, right? Earlier. Okay, so that should conclude today's lecture. Let's see if this works. Yeah, it compiles on, yes, string stack 1, and 1 meaning true, right? Meaning this is bigger. And why is it bigger? Because I said so, right? Because I said so, because I am comparing by top. But of course, I could compare by something else, by something like this, such as size, right? For example, right? Or maybe combination of criteria. All right. What else do we need today? I think that's it. Yeah, we have a file information, a class template, right? And of course, you can combine them in the headers templates, right? So array-based lists, right? You can make an array, right? So it's widely used. We'll be using these then generics and make more complicated structures. Maybe we'll make a bigger stack later on, right? Maybe more universal. So again, by using this T, right, we allow a generic use of our functions, a generic use of our class templates, basically. So any questions today? Makes sense?
Yeah.
Okay, so about the midterm, right? So 9 o'clock sharp. Again, be ready to read some text files, basically, right? You have, that's just the basics, like to get out of bed, sort of requirement. All right. So I'll see you on Thursday at 9. Thank you, everyone.